Hello everyone, in this video we will discuss the memory based question of CSIR-NET and question number 22, and this question is from part C. Question is, for a given order of group, which of the following classification is are possible, and options are this. Now in this question we have to find out the possibility of classification for a given order group. For this question, firstly we have to understand the concept of classification of a group of finite order. Now classification of a group we means the representation of order of G equals to 1 plus 1 plus 1 up to order of ZG times plus summation of order of conjugate class of A, that A not belongs to ZG and A run over each conjugate class in G. Now result second, as we know that ZG, that is center of group, is subgroup of G. Then by using Lagrange theorem, order of ZG divide order of G. Result third, that is order of NA is equals to order of G upon order of conjugate class of A, where A belongs to G. Now N of A means set of B where B belongs to G such that B commute with A, and conjugate class of A means set of B where B belongs to G such that B relate with A. Now result fourth is, as we know that center of group, that is ZG, is a subgroup of NA for every A belongs to G. This implies that by using Lagrange theorem, order of ZG divide order of NA. Now come to further explanation. For option A, we have given that 14 is equals to 1 plus 1 plus 2 plus 2 plus 2 plus 2. This implies that we notice that from this classification, order of ZG is equals to 2 because 1 repeat 2 times. That is order of ZG is equals to 2. Now this 2 implies order of conjugate class of A where A not belongs to ZG. Now for A node belongs to ZG, order of conjugate class is equals to 2. And now using result 3, order of NA is equals to order of G upon order of conjugate class of A. This implies 14 upon 2, that is equals to 7. Now result 4, ZG is a subgroup of NA for every A belongs to G. This implies that order of ZG divide order of NA. This implies that 2 divides 7, but this is not possible. This implies that this classification of a 14 order group not possible, that is option A is incorrect. And for a 14 order group the result is either order of center of G is equals to 14 or order of center of G is equals to 1. Also using this result, this option incorrect. Now come to option B. In option B we have given that 15 is equals to 1 plus 1 plus 2 plus 3 plus 3 plus 5. From this classification we notice that order of ZG is equals to 2 because 1 repeat 2 times. Now we know that ZG is a subgroup of G. Then by using Lagrange theorem, order of ZG divide order of G, that is 2 divide 15, but this is not possible. This classification is not possible, that is this representation of 15 order group is not possible, that is option B is incorrect. We can also use result, that is if order of group is 15, that is 3 into 5, order of ZG in this case always 15. Also using this result we can discard this option, that is we can say that this option is incorrect. See, we have given that the class representation of 21 is equals to this, that is 21 is equals to 1 plus 3 plus 3 plus 7 plus 7. From this classification we notice that order of ZG is equals to 1, that is ZG contains only identity element of a group. Now for conjugate class, that is A not belongs to ZG, that is A not equals to identity elements. Result 3, order of NA is equals to order of G upon order of conjugate class. This is equals to 21 upon order of conjugate class, which is either 3 or 7. This implies that 7 or 3. Now from this information it is clear that all the results 2, 3 and 4 are satisfied. So we cannot say anything about this class equation. Now for this we also have a result. As we know that if order of group is equals to 21, that is equals to 3 into 7, it have only two possibility, that is abelian or non-abelian. If a group is abelian, this implies that its class equation is this, because if abelian, this implies that g is equals to zg, order of g is equals to order of zg, that is one repeat order of zg time, that is one repeat 21 time. Now if g is non-abelian, this implies that its class representation is 1 plus 3 plus 3 7 plus 7. I have proof for this class equation, that is, for this proof, firstly we have to remember the result, that is if order of g is equals to n is equals to pq form, where p and q are distinct primes such that p less than q, then one class equation of g, that is order of g is equals to 1 plus p repeat q time plus q repeat y time, that is for a 21 order group, is equals to 1 plus 3x plus 7y, that is 3 repeats x time and 7 repeat y time. Now come to proof. We have given that G is a non-abelian group of order 21. This implies that by using a Silo third theorem, G has a unique 7 Silo subgroup. G has a unique Silo 7 subgroup. That is, G has a unique subgroup of order. Also, G is a non-abelian group of order 21, and its generating relationship is A comma B, such that order of H 7, that is A7 is equals to E, and order of B is equals to 3, that is B3 is equals to E, and B inverse AB is equals to A square. In this proof, I use the concept of conjugate class, because in a class equation, conjugate class concept is very important. Now, in a generating relation, order of H 7, this implies that A power 7 is equals to E. This implies that A comma A square comma A cube up to A6 are the element of order 7, because G has a unique subgroup of order 7, and G has 6 element of order 7. Now using generating relation B inverse A, B is equals to A inverse. Now from the definition of conjugate class, that is, in conjugate class, this is the mean, that is, this element belongs to conjugate class, but this element is equals to this implies that A square is belongs to conjugate class of A. Now in this relation, if we pre-multiply with B inverse and post multiply with B, this equals to B power minus 2 A, B power 2 is equals to B minus 1 power A power 2 into B is equals to A power 4. This implies that A power 4 belongs to conjugate class of A. That is, again iteration these steps and we get only 3 element in conjugate class of A. Similarly, conjugate class of A cube, this 6 element, this implies that there are only 2 conjugate class of order 3. That is, value of x is equals to 2. Now come to star equation, that is, we have 21 is equals to 1 plus 3x plus 7y. X is equals to 2 because we have only 2 conjugate class of order 3. From the previous discussion, this implies that 21 is equals to 1 plus 6 plus 7y. That is equals to 14 is equals to 7y and y is equals to 2. Now this implies that 21 is equals to 1 plus 3 into 2 plus 7 into 2. This is equals to 21. This implies that 3 repeats 2 times and 7 repeat 2 times. That is 21 is equals to 1 plus 3 plus 3 plus 7 plus 7. This implies that option C is correct. Now come to next option. Now in option D, we have given that 39 is equals to, that is, class representation of order 39 is equals to 1 plus 3 plus 3 plus 3 plus 3 plus 13 is plus 13. We notice that order of ZG is equals to 1. That is, ZG contain only identity element and satisfy all the results 2, 3, 4 because for A not equals to identity element, order of NA is equals to order of G upon order of conjugate class, order of G 39 and order of conjugate class either 3 or 13. This implies that 13 or 3. Now we cannot say anything about this classification, so we also have a result for 39 order group. If order of group is equals to 39, it's have only two possibility, Abilene group and non-Abilene group. For Abilene group, we know that ZG is equals to G, order of group is 39. This implies that order of ZG is 39, that is one repeat 39 times. This implies that this is the class representation of Abelian 39 order group. Also, if G is a non-Abelian, in this case, class representation of a 39 order group is this. That is 1 plus 3 plus 3 plus 3 plus 3 plus 13 plus 13. I also have proof for this. That is, proof is as we know that 39 is can be represented as 1 plus 3, that is 39 is equals to P into Q form where P less than Q. 39 is equals to 3 into 13 where 3 less than 13, that is 1 plus Px plus Qy where 3 repeats x time and 13 repeats y time. Now as we know that G is a non-Abelian group of order 39, so by using Silo third theorem, it has a unique 13 Silo C subgroup. That is G has a unique subgroup of order 13. As we know that if order of group is 39 and G is a non-Abelian group, then G can be represented in generating a relation that is A comma B such that order of A is 13 and order of B is 3, that is A power 13 is equals to E equals to B power 3 such that B inverse is equals to A power. This implies A power 13 is equals to identity element. This implies that A comma A power 2 comma A power 3 comma A power 4 up to A power 12 are the element of order 13, because we know that if G has a unique subgroup of order 13, then G has phi of 13, that is 12 element of order 13. Now from given generating relation we have B inverse is equals to A power 3. This implies that A power 3 belongs to conjugate class, because we know that by the definition of conjugate class of A contain the element B such that B belongs to G and B relate with A. That is, we notice that here this B relate with A, that is B inverse mean B relate with A, that is A power 3 belongs to conjugate class of A. Now again pre-multiply with the B and post-multiply with the B inverse. This implies that B power 2 A B power minus 2 is equals to B A power 3 B minus 1 is equals to A power 9, because for A we have A3, now for A3 we have A9. This implies that A power 9 belongs to conjugate class of A. Again and again using the iteration, this iteration we get only 3 elements in conjugate class of A and order of this conjugate class is equals to 3. Similarly using the above technique we have 4 conjugate class of order 3. This means that x is equals to, from the previous discussion we have x is equals to 4. This implies that 39 is equals to 1 plus 3 into 4 plus 13y. After some calculation we have 26 is equals to 13y, that is y is equals to 2. This implies that as we have 39 is equals to 1 plus 3x plus 13y, this implies that x is equals to 4 and y is equals to 2. That is 39 is equals to 1 plus 3 into 4 plus 13 into 2. This implies that this 3 repeat 4 time and this 13 repeat 2 time. That is 39 is equals to 1 plus 3 plus 3 plus 3 plus 13 plus 13. And this match with our option D. This implies that option D is correct. Now come to option again. That is Option A is incorrect, option B incorrect, option C correct, option D correct.